Hi, Dick. What happened? अरे सर हेडेक. Why? पूछिए मत सर. इतना मैथ थ्योरी कौन पढ़ाता है? बच्चों की जान लेंगे क्या? समझा. मैथ थ्योरी पढ़ के परेशान. सॉल्विंग प्रॉब्लम्स लाएगा होठों पे मुस्कान. वेलकम यूट्यूबर्स. कैसे आप सब लोग? आशा करता हूँ आप सब लोग बहुत अच्छे होंगे. As we have said, in today's video, we are going to solve some problems of three-dimensional geometry, exercise 11.1 of NCERT CBSE board. So without wasting any time, let's go to the blackboard. So here is the first problem. If a line makes angles 90 degree, 135 degree, 45 degree with XYZ axes respectively, find the direction cosines. So here, first we draw the Cartesian coordinate system in three-dimensional space. X, Y, Z, this is origin. Solution. Now a line is given in such a way that it makes angle 90 degree with x-axis, 135 degree and 45 degree with y and z axis respectively. So from lecture 1 we can say easily that the direction angles of this line are given. So here direction angles of say of line say AB vector are alpha equal to 90 degree, beta equal to 135 degree, gamma equal to 45 degree. So again from the lecture 1 we can say easily that if alpha, beta, gamma are the direction angles of a given line, then cos alpha, cos beta, cos gamma are what? Direction cosines. So therefore direction cosines of the given line a vector are cos alpha means cos 90, cos 135 degree, cos 45 degree. Now we will use the values of trigonometric ratios in the next page. Here I have chalked down all the values of trigonometric ratios in tabular form. We have to memorize all these values to easily solve the problems in examination. But if some of you have some problem to memorize these values, here it is a very easy way. I have shown you here to memorize all this, to write down all these things in the examination hall in a rough page like this way. Take the square root. Write simply 0, 1, 2, 3, 4, divide them by 4, then take square root. Take square root. So here is the values 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. These are nothing but the value of the trigonometric ratio sine for the angles 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. Here I have written in this first row. What are the values of cos? We just make it reverse. So these are the values of cos. And what are the values? How to obtain the values of tan? Tan theta equal to sin theta by cos theta. We know this relation. So take this 0 by 1 is 0. 1 by 2 by root 3 by 2 means 1 by root 3. 1 by root 2 by 1 by root 2 is 1. So tan 45 degree equal to 1. So like this table is derived. Okay. So without wasting any time, again go to the problem. So here cos 90 we know that, cos 45 degree we know, but cos 135 degree, how to derive this? Here cos 135 degree equal to cos 1 into 90 degree plus 45 degree. Here we will use the all sine tan cos rule of trigonometry chapter. here it is x o x dashed y o y dashed. This is first quadrant, this is second, this is third, this is fourth. So the rule is all sine, tan, cos. So all the trigonometric ratios remain positive, takes positive sign in the first quadrant. Here sine and cosec takes the positive sign, other trigonometric ratios will take negative signs. Here tan and cot takes positive sign, other trigonometric ratios will take negative signs. Here cos and sec will take positive sign and other trigonometric ratios will take negative signs. So here cos 1 into 90 degree, here it is 1, so cos will change to sine, and 45 degree we will write as it is. Then here we will find the position of the angle. So 1 into 90 degree, complete 90 degree and 45 degree. So this angle resides in the second quadrant. So in that quadrant, except sine and cosec, all takes negative sign. Here it is cos, so it will be negative sign. This we will already learned in previous classes, but for your convenience I again explain this to you. I think it may be helpful. So minus sine 45 degree, so minus 1 by root 2. Here sine 45 degree, what is the value of sine 45 degree? See the previous table, sine 45 degree 1 by root 2. Cos 90 is from this table 0. Here cos 90 0. So 0 minus 1 by root 2 and another value cos 45 degree, again 1 by root 2. Not like that. Here we will use that sign. Therefore these are the direction cosines of the given line solved. So we have solved the first problem, very easy problem. So we go to the next problem. Find the direction cosines of a line which makes equal angles with the coordinate axis. So let us assume that the given line, say AB vector, makes equal angle alpha with the three coordinate x, y, z axis. Therefore, so alpha is the direction angles of the line AB vector. Therefore, direction angles of AB vector are alpha, alpha, alpha. We have used the concept of lecture 1, right? So again from lecture 1, if alpha, alpha, alpha the direction angles of the line AB vector, then direction cosines are what? Cos alpha, cos alpha, cos alpha. Therefore, very easy. Nothing is there. Therefore, direction cosines of AB vector are cos alpha, cos alpha, cos alpha. Again, what we have learned from our previous lectures, particularly say lecture 3 maybe relation between the direction cosines of a line segment is L square plus n square plus n square equal to 1, where element are nothing but the direction cosines, that is cos alpha. Here in this case cos alpha, cos alpha, cos alpha. So we get to the next page. By using the relation between the direction cosines of a line, we may write cos, first we write the relation L square plus n square plus n square equal to 1, that is in that problem cos square alpha plus cos square alpha plus cos square alpha equal to 1 implies 3 cos square alpha equal to 1 implies cos square alpha equal to 1 by 3 implies cos alpha equal to plus minus 1 by root 3. So therefore the direction cosines of given line are plus minus 1 by root 3, 1 by root 3, 1 by root 3. Solved. Here we have solved the problem number 2. Now here we have written plus minus sign before the direction cosines. What does it stands for? From the lecture 1 we have already learned that for any line segment we have two sets of direction cosines. That was the theory. Here is the application of that theory, right? So to get a unique set of direction cosines of a particular line segment, we have to fix the direction of the line segment. So to understand all the concepts of three-dimensional geometry, you have to go from stepwise. So first you have to learn lecture 1, 2, 3, 4, then come to lecture 5, that is this lecture, and solve the problems. Then you can easily understand all the concepts hidden within the problems. So now we move to the next problem. If a line has the direction ratios minus 18, 12, minus 4, then what are its direction cosines? This problem will be given as home assignment. Hint, I will give some hint. In that, while solving this problem, you just go through the theory. If direction ratios of a line are given, how to find direction cosines. I have taught that particular theory in lecture, I think 2. So please go through lecture 2 and solve this problem and put the answer in the comment section below. This will motivate me. मुझे तो पता चले कि कोई स्टूडेंट पढ़ रहा है, मैं जो लेक्चर दे रहा हूँ, जो भी मैं डाल रहा हूँ यूट्यूब में, कुछ हेल्प कर रहा है आप लोगों को। अगर ये मैं देखूँगा कि कोई प्रॉब्लम सॉल्व किया और कमेंट सेक्शन में इसका आंसर दिया, तो इट विल मोटिवेट मी अ लॉट. थैंक यू फॉर वॉचिंग.